Okay. So yesterday we were talking about those standard deviation and all those kind of concepts. What is the depth and then, I'm sorry, not the depth, the dispersion and all those things we were talking about. Today, we shall start with a very important topic of statistics, which is called hypothesis testing. Possibly it's the most conceptual and the most important aspect of statistics that we are going to cover. And we are going to make use of it whenever we are working on statistical aspects, or maybe whenever we are dealing with any program as such. Program means interaction between a client and the organization. At that point of time also, hypothesis becomes a very important aspect. So hypothesis testing. So there are few things that we first need to understand, few fundamentals that we need to understand. If I talk about hypothesis testing from a very superficial level, let's start from a very superficial level right now. The aspect of hypothesis or the kind of hypothesis that we have are two different kinds of hypothesis we have. For example, we have something called H0 and we have something called H1. H0 is also called null hypothesis and H1 is called alternate hypothesis. So this is your null hypothesis and this is your alternate hypothesis. So if we wish to create a null hypothesis, how can we do that? If we wish to create an alternate hypothesis, how can we do that? That is the next question. But before even going to that, one important thumb rule we need to remember with respect to hypothesis always is that we try to reject the null hypothesis every time. This is actually, you can say, the objective. Every time we will try, okay, we cannot claim that, okay, every time we will be in a state to reject null hypothesis, but we will try. Okay, that is the objective. We will try to reject the null hypothesis. Why do we do that? We will realize that in next 5-10 minutes. Okay, so this is the thumb rule. If we are able to remember this small point, it becomes easy to work on the problems. So when we say that we try to reject the null hypothesis, let's now understand that what exactly do I mean when I say null hypothesis and alternate hypothesis. As of now, we have understood that hypothesis testing involves two aspects or involves two kind of hypothesis. There is something called H0, which is null hypothesis, and then there is something called alternate hypothesis or H1. Okay. Now we will be taking up a lot of case studies today, tomorrow, in the subsequent lectures. We will be taking a lot of case studies and examples so that this understanding becomes very clear to us. So let's say we are taking the first case study right now. Okay. So here, let's imagine, okay, let's imagine that we have this mobile manufacturing company, let's say OnePlus. Okay, so OnePlus is a mobile manufacturing company, and like it's into a lot of things also, like not just mobile, it's also into TV and all those things. So let's say OnePlus is a company, and this company has manufactured a new mobile phone altogether. Okay, it has manufactured a new mobile phone altogether. Fine, no problem. Now the company OnePlus says The company OnePlus says that this mobile phone is a flagship mobile phone of their company, and this mobile phone will make sales of, let's say, $1 million. Okay, $1 million globally. Okay, this is what the company owner or people like that are saying, 1 million globally. Okay, this is what the company has to say. Right now what happens is, based on this information, only this much will be given to you. Okay, and you will be asked to create the hypothesis for this. Okay, you will be asked to create the hypothesis for this. So how do we do that? I told you that hypothesis that we develop are of two types. You have one hypothesis called H1 and the other one is H0. So let us first create them. Let us first write them. Okay. So for this particular context given to us, let us say H0 is what? H0 is going to be the same thing which is mentioned in the problem, or which is mentioned in the I can say case study. Okay, that means when I say H0 is same as the context, H0 in this case will be what? Sales of 1 million. Okay, sales of 1 million. This is what the question says, or you can say this is what the context says, and exactly the same thing will be represented here also. Exactly the same thing will be represented as H0 also. So whatever is there in the context, whatever is there in the question, that becomes the H0, or you can say H0 is nothing but the claim of the company. Okay, this is the claim of the company. Why? Because the owner of OnePlus has mentioned this, that the mobile phone, this new mobile phone, will be making a sales of $1 million globally. So whatever the claim of the company is, that becomes your H0 without any modification. You are not doing anything. You are not doing any alterations, no modifications, nothing. Whatever is there in the question, whatever is being claimed by the company, that becomes your H0. Fine. What is H1? H1 is alternate hypothesis, isn't it? Alternate means opposite, alternative. Yeah. So if you are not taking path A, you can take path B. So that is the alternative. So if H0 says that sales of 1 million is going to be there for this new mobile phone, H1 will be exact opposite of it. So H1 will say sales not equal to $1 million. This is what we can say, because in H1, H0, what we are saying? We are saying that the sales is going to be $1 million. This is how we can say sales will be $1 million, because that is what is mentioned in the question or in the context. So same way, if I'm talking about H1, what happens here? I will say that no, it will be opposite of what H0 says. And because H0 says that sales will be $1 million, H1 will say sales is not equal to $1 million. Okay, this is how initially we develop H0 and H1 depending upon the context given to us. Okay, depending upon the context given to us, H0 will say sales is $1 million. Why? Because that is something which is mentioned in the question, and H1 will be the reverse of it, the opposite of it, and H1 will say that sales is not equal to $1 million. Okay.
Yeah.
Now, if we dive deep into this, what do we observe? Here I am saying that sales is not equal to 1 million, isn't it? When I say sales is not equal to 1 million, there are two conditions which can develop. For example, when I say sales is not equal to 1 million, Sales can be greater than $1 million, isn't it? Sales can be greater than $1 million. Sales can be less than that also. Sales can be less than $1 million also. Is this idea getting clear? When I say sales is
Yes.
not
Yep,
equal
I'm
to 1
following.
million.
Yep.
When sales is not equal to 1 million, that means sales can be more than 1 million or it can be less than 1 million. Yes. So what do we observe? What did I say initially here? What was the thumb rule for us? We try to reject the null hypothesis. So what is null hypothesis? Sales is equal to 1 million. Yes, sales is equal to 1 million. So here, what do we observe? In this particular case study, in order to reject H0, we have two conditions, one condition and the second condition. If any of these two conditions is satisfied, this will get rejected. Don't you think so? If sales is more than 1 million, this condition gets rejected, H0 condition. If sales is less than 1 million, even then this condition gets rejected. So two conditions you have inside H1. Inside H1, you have two conditions. If any one of them gets satisfied, H0 gets rejected. So such a condition or such a case study will be known as, or we will classify this as a two-tail hypothesis test, or you can simply say two-tail test. Okay, this is called a two-tail test. Why is it called a two-tail test? Because you have two conditions for rejecting H0, which is your thumb rule, which has to be taken care of every time. In order to do that, in order to reject H0, you have two conditions. Sales greater than 1 million, sales less than 1 million. So because we have two conditions inside H1 to reject H0, that is why this kind of a test is called a two-tailed test. Till here things are fine?
Yep, fine. I'm following it.
Okay. There are a few more like observations which we will make, but as of now, we will move to the next case study. We'll come back to this case study again after 10 minutes. But as of now, let's get into the another one. To understand it better, let's get into the next case study. So let's say the second case study which we have is okay. Let's say I want to rent a house. Okay, so I want to rent a flat. Let's say I want to rent a flat. Fine. Now the problem is I want to rent a flat. My budget is, let's say, 10,000 rupees per month. Okay, my budget is 10,000 rupees per month. Fine. My budget is 10,000 rupees per month. Now what happens is, depending upon this, because I want to rent a flat, what I do is I go to this person, this broker, or let's say this middleman that we have, who will show me the flat, and then we will basically do some negotiations and all. So the broker which we have, or the agent, broker shows flats with a rent of range, let's say 7,000 rupees per month to, from 7,000 he shows to 30,000 per month. Okay, so the upper limit of the rent that he showed was still 30,000. Okay, 30,000 per month. Now, based on this context, we need to develop your H0 and H1, and then we also have to identify that whether this is a one-tailed test or a two-tailed test. Okay. As of now, we have understood that this is what? This is a two-tailed test. Why is it a two-tailed test? Because we had two conditions inside H1. If we have just one condition inside H1, then what we will say? It is a one-tailed test, simple. So if I come back to this example, this case study, I want to rent a flat. My budget is 10,000 per month. Broker shows a flat which is ranging from, let's say, 7,000 per month to 30,000 per month. Now, depending upon that, I need to create H0 and H1. So H0 will be what? H0 is what exactly is given in the question. So in this context, I will say that H0 will be rent of the flat, because I want to rent this house. I want to rent some house. So I will say that rent will be less than equal to 10,000. Can I say that? Per month?
Yeah.
Because if I get a flat of, let's say, 5,000 rupees, I will definitely be able to manage that. But if I get a flat of, let's say, 11,000 per month, it's more than my budget. I don't have that much amount of money. So I cannot purchase that, or I cannot rent that. So that is why H0 will be rent less than equal to 10,000 per month. So what will be the opposite of it? H1?
Greater than or equal to.
Not equal to, only greater than.
Greater than.
Rent will be greater than 10,000, because what is the ultimate objective of H1? It is going to be the reverse of what H0 is. So rent will be greater than 10,000 per month. Yes. Now just observe this. In order to reject H0, how many conditions do we have? Just one condition.
Just one, yeah.
So this
So it's
is
one
example of a one-tailed test. This is example of a one-tailed test. Now, when we say one-tailed test, we also have to specify that whether it is a left-tailed test or a right-tailed test. Okay. If it is a two-tailed test, then things are fine, no problem. But in case it is a one-tailed test, we will have to specify that whether it is a left tail or a right tail test. So let's understand that aspect also. Then we will come back. So I'll draw that here. Okay. So let us assume it in this manner. Just assume that all three of them are of same shape and size. However, they are not, but just imagine that they are. Okay. So what happens is, let us say this is a two-tail test example that I'm drawing. This is a two-tail test. Okay. And these two are what? These two are one-tail test. And when I say one-tail, we will have to specify whether it is a left-tail test or a right-tail test. Yes. So just imagine for some time let's say this is left tail test graph, and this graph is with respect to right tail test. Okay, just imagine for some time. Okay, now when I say that it is a two-tailed test, what happens is on both the ends, that means this side also and this side also, something called rejection region will get created. So this shaded area is the rejection region. Similarly, this shaded area is the rejection region. Rejection region for what? Rejection region for my H naught. That means if the value of H naught lies in these region, okay, if the value of H naught lies in these region, what happens is we will be in a state to reject H naught. Okay, we will be in a state to reject H naught, and that is why, because we have two rejection regions getting created, one on the left side and another one on the right side. That is why this graph is with respect to two-tailed test, because we have observed that two-tailed test is what? A condition where you have two conditions or two circumstances or two conditions to reject H naught. Okay, so this is how the graph of two-tailed test looks like. You have rejection region on both the ends, on left side also and on the right side also. So if that is true, if that is something which you are observing, it means that you are talking about two-tailed test. Okay. Similarly, if I'm talking about one-tailed test, if I'm talking about one-tail test. So in such cases, what happens? You will have either left tail test or right tail test. If it is left tail, then what can we say? Rejection region to reject H naught gets developed where? On the left side. Yes, on the left side. Similarly, if it is a right tail test, then what will happen? Same thing. Rejection region will be developed on the right side of the graph. Simple as that. Okay. That means if you are having a right tail test and if the value of H naught lies in this region, then what will happen? We will be in a stage to reject H naught. Similarly, if it is a left tail test and the value of H naught lies in this region, then what will happen? We will be in a state to reject H naught. Okay. Now a question arises. What is the question? Question is, how do we know that whether this value, that means I'm trying to say that here I have mentioned arbitrarily that this is the point from where rejection region starts. Yes, I have arbitrarily mentioned that this is the point from where your rejection region starts. Similarly, here also, same thing I have done. Arbitrarily, I have drawn a line and I have mentioned that from here onwards, the value of H naught, if we have, that is going to be regarded as the value of H naught in the rejection region. Similarly, here also, same thing I have done. I have drawn these lines arbitrarily. I don't have a specific formula or a specific technique of doing that. Yes. So how do we develop these rejection regions? How do we develop these rejection regions? For that, we have to get into something called the validation techniques. For example, you have something called Z test. You have something called T test. You have something called ANOVA. You have something called chi-square test. So all these validation techniques that we have, when we study them one by one, I don't know whether we'll be able to do that today or not, but if we start from tomorrow also, there is no problem as such. So when we start talking about these tests, over there, you will realize that we will refer a lot of tables. For example, we will refer Z table, we will refer T table, we will refer your, let's say, chi-square table. Okay. So the values that we get from those tables will help us in identifying these points which I have highlighted in yellow color. So the exact point from where your rejection region is going to start, how do we get that point? Using the validation techniques. So for that, we will have to wait. I think till tomorrow we will have to wait. But the idea is we can develop that. We can generate that. Whether it is a two-tailed test or a one-tailed test, we can generate the exact point from where your rejection region has to start. But for that, we will have to refer those tables, as I told you, Z table, T table, all those tables, we will have to refer. Only then we will be in a state to tell that, okay, for this graph or for this problem, the rejection region starts from this particular point. So that exact value we'll be able to generate from the table. Apart from that, something very, very important that we have to understand with respect to entire hypothesis, not just for this example, for entire hypothesis, one very important concept that we need to understand is something called level of significance. Very important concept. Okay. So there's something called level of significance. I'll just mention it here. Level of significance. It is symbolically represented as alpha. Okay. It is symbolically represented as alpha. And we can say level of significance or alpha is nothing but 100 minus level of confidence. Hundred minus level of confidence. This is what your level of significance is. Now, what do I mean by that? Let's say I'm taking a test of yours. Tomorrow, I'm taking a test of yours on, let's imagine, Python. I'm taking a test of yours on Python tomorrow. Now, when I'm saying that I will be taking a test of yours on Python, you will have some sort of confidence within yourself that, okay, if I'm giving you, let's say, 10 questions, then at least you will be able to solve 7 questions out of them. This is the confidence that you will have, or maybe 8 questions you'll be able to solve, or maybe, 9 questions you'll be able to solve. So what is this? This is the amount of confidence that you have in yourself. This is the amount of, I can say, trust that you have on your preparation, on your, let's say, efforts, right? All these things you have. So that is what your level of confidence means. When you subtract that level of confidence from 100, the remaining stuff that you get is called level of significance. For example, here, when I say that you have OnePlus company, you have this company called OnePlus, and I'm saying that this OnePlus company claims that they will be able to make sales of $1 million globally. Now, when they're making this claim, they must have some sort of confidence on the kind of product they have produced. They will have some kind of confidence on their resource people, on the amount of effort the technical team has made, the amount of effort the assembling team has made, all those kind of things. So they must have some sort of confidence on their people as such, on their resources as such. Yes. And only then they are saying that, okay, they will be able to make global impact of, let's say, $1 million, right? So let's imagine that the amount of confidence OnePlus has on its resource people, on its manufacturing unit and all those things is, let's say, 90%. Let's imagine, okay, that when OnePlus says that, okay, I will be in a state to produce, when OnePlus says that I will be in a state to generate $1 million of profit or sales of $1 million globally, okay, the amount of confidence 1 plus has is 90%. So I'll just write it down. Confidence of 90%. For example, in schools or in colleges also, when we come out of the examination hall, we talk to our friends and we say that चलो यार pass तो कर ही जाएंगे. Yes. So pass कर ही जाएंगे इस चीज का क्या guarantee है? What is the guarantee of that, or what is the amount of confidence that you have on yourself that yes, you are definitely going to pass? है ना? So same thing. Confidence of 90%. Now, for us, actually, level of confidence is not very important. For us, level of significance is important. But the problem is we can derive level of significance with the help of level of confidence only. So that is why when 1 plus claims that they will be able to make sales of $1 million globally with a confidence of 90%, for us, the important part to understand or to derive from this is, for us, alpha value from this question, for us, alpha value from this question is how much? 10%, or you can say 0.01. 10% or 0.01. This is the value of alpha, which is more important for us. For us, confidence is not that important. For us, level of significance is more important. That is why I have given you the formula. Level of significance, which is alpha, is nothing but 100 minus level of confidence. Because level of confidence is 90%, 100 minus 90 is 10%. So level of significance is 10% or 0.01. This point is clear? Yeah, Divakar, is it clear?
Sorry about that, Ashutosh. I don't know what happened just for a minute.
Yeah, no problem. Yeah.
Yeah, let's continue.
So we were talking about this level of significance. So I think that part is clear.
Yeah, yeah.
So if this is clear to us, one more
Yes.
dimension that we have to look into is that when I say confidence of 90% means significance of 10%, that is fine. Now when we were talking about this one tail and two tail test, especially here, you will have to take into consideration before you develop the rejection region that I told you will be able to develop using the tables which we have, Z table, T table, and all. So before you try to develop the rejection region, you will also have to remember that whether the level of significance you are using is appropriate or not. For example, when you are talking about a two-tailed test, because there are two rejection regions, that is why whatever alpha value you have, that gets divided. So here alpha by 2 and here alpha by 2. Okay, this is what happens in a two-tailed test. Whatever alpha value you have, whatever level of significance you have, that gets divided into two parts because you have two rejection regions getting developed. Okay, but in case of one-tailed test, it remains as it is. That means only one rejection region we have, and here we will consider only alpha. Similarly, in case of right-tailed test also, just one rejection region we have, so just alpha. Okay, this is a small point, but this will make a lot of difference in the rejection region value that you will have to consider. Because when we refer the tables, Z table, T table, whatever, over there we will have to emphasize on level of significance also. So if you have a one-tailed test and you are dividing alpha by 2, then possibly you will land up to a wrong conclusion, a wrong output. Okay, a wrong rejection region. So that is why considering alpha value is also important. What is alpha? Level of significance. And how do we derive that? By subtracting level of confidence from 100%. This is what we have understood. So for this particular example, if the confidence is 90%, alpha is 10%, because it is a two-tailed test, so what will happen to alpha? Alpha will get divided by 2. This point is
5%.
5%.
5% on each side, you mean?
5% on both sides. So 5%
Yeah.
on the left side, 5% on the right side. Correct.
Yeah. Yeah.
Okay. Similarly, in this example, the one that we were talking about, here I say that my budget is 10,000 rupees per month. All these things I'm saying. Let's say here the confidence with which I am saying this, is 95%. Let us assume confidence is 95%. So alpha becomes how much? 5%. Simple. Alpha becomes 5%. Now, because it is a one-tailed test, we have just observed it is a one-tailed test. So it remains as it is. Alpha remains as it is. Okay. Till now, we have not understood whether it is going to be a left-tailed test or a right-tailed test. But whatever may be the case, even if it is a left-tailed test or even if it is a right-tailed test, what happens is you will not have to consider alpha by 2 value. You have to consider alpha value only because it is a one-tailed test. Okay, till here things are fine.
Yep, all good.
Okay. Now let us exactly understand that how can we say that whether this test is a one-tailed test or a two-tailed test. Very simple approach we will follow. No complications. Very simple approach we will follow. Let's say I'm drawing a number line here. Number line, not exactly a number line, but something similar to that. What happened to the screen? Just a second, let me reload that. Okay, so now let us understand that when I say it is a one tail test, let us understand whether it is a left tail test or right tail. Very simple technique. Let's say this is 10,000 per month. Okay, 10,000 per month. Fine. So anything on the right side will be more than that. Let's say 11,000. Let's say 12,000. Yes. Till how much? Till 30,000. Why? Because the broker, he showed me the house or the flat which were in the range of 7,000 to 30,000. Yes. So 11,000, 12,000, and all those things I will have on the right side. And on the left side, what we will have? Let's say 9,000 per month. Let's say 8,000 per month flat. Let's say 7,000 per month flat. Yes. Something like that we will have. Not less than that, because the broker showed me till here only. So let's say till here I'm having the graph. Fine, no problem. Now H0 says rent will be less than equal to 10,000. That means less than equal to 10,000. This part, yes, this part of the graph, less than equal to 10,000. That means 7,000, 8,000, 9,000, and 10,000 also. So this much area of your graph which you have, this much area of the graph that you have is actually denoting what? Sorry. This much area of graph is actually denoting what? It's not
acceptance region.
basically H0 it is showing, because H0 is less than equal to 10,000. So same thing is being reflected here. So this part of our graph, this part of our graph is showing what? H0. Now I want to do what? I want to reject H0. Yes, I want to reject H0. That is the thumb rule which we have understood. Always we try to reject H0. So in order to reject H0, in which direction should I go? In this direction or in this direction?
Right.
Obviously in this direction. Yes. In order to reject H0, I will go in the right direction. So that is why what will this happen? What will this become? This is a one tail test, fine. But what sort of one tail test? Right tail test. Agree?
Yeah.
This is a right tail test. One tail test, fine. But what sort of one tail test? Right tail test. So this is how we make the conclusion. This is a right tail test. This is a right tail test. Now, this is a right tail test. Alpha remains as it is. H0, H1, confidence level, significance level, all these things we have understood. Just take 2 minutes, try to recapitulate all these things. Tell me if you have any questions. Then we will proceed. We will solve one more case study. I'll give it to you. You will try to solve that, and then we will move ahead. Any doubts if you have, you can ask me.
No, I'm good, Ashita. I'll do that.
Okay. So, acha, one more thing. However, it's not something new. Definitely, if I ask you to create your bell-shaped curve for this particular case, you can do that very easily. You will just take these axes and then you can create a bell-shaped curve. I'm not getting into the values of rejection region, but a basic graph like this you can definitely draw. This is a right tail test. That means rejection region will be in this side. This kind of a rough graph you can draw for your convenience. Right. So This is what this problem would infer. Fine, no problem. Now, let us solve one more case study. Let us solve one more case study. And I would like you to work on that actually. Just a second. Okay. So the third case study that we are going to work on is with respect to a manufacturing company. So let's say a straw manufacturing company we have. Okay. Straw manufacturing. Okay. Let's say this straw manufacturing company visits me. They visit me. And what do they claim? They claim that average, just a second. They claim that average radius of pipe or of straw that they make. Okay, average average radius of straw that they make is how much? 0. Or let's say is less than equal to 0.05 millimeters. Okay, less than equal to 0.05 millimeters. Okay. Then yeah, less than equal to 0.05 millimeters. Based on this simple context, you have to develop H0 and H1. What will be H0? What will be H1? You have to derive. Then you have to tell me the alpha value. Okay, I'll tell you what is the level of confidence. You have to tell me the alpha value, and then you also have to tell me based on H0 and H1. You have to tell me whether it is a one tail or a two tail test. One tail or two tail test. You have to tell me if it is a one tail test, so left tail or right tail, that you have to tell me. And finally, the graph. How is that graph, rough graph, going to look like? That you have to tell me. Okay. So what is the level of confidence for this straw manufacturing company? Confidence of 90%. These things will be given to you in the question, need not worry. These things will be given to you in the question. So level of confidence will be given to you as 90%, or directly to make things simpler, they will give you the level of significance as 10%. So either of these two things will be given to you. Either they will directly give you level of significance or they will give you level of confidence. So in either cases, you will be able to work. Okay. So just try to answer these questions.
Yeah. Okay. Okay. So, can you hear me?
Yeah.
Yeah, so the null hypothesis is H naught is less than or equal to 0.05 millimeter.
Hmm.
Alternative hypothesis is H1 greater than 0.05 millimeter.
Hmm.
So we give the level of confidence. This is a one-tailed test, so the alpha is 10%. And this will be, if you put it on a graph, it will be one tail right side test. The rejection region will be on the right hand side.
Okay, fine. Correct. So what have we observed? H naught will be, I'll just write it down quickly. H naught will be radius, whatever is given in the question. So less than, just radius less than equal to 0.05 millimeters. H1 will be opposite of it. So I will say H1 is radius greater than 0.05 millimeters. We just have one condition inside H1 to reject H0. That is why it is a one-tailed test. It is not a two-tailed test. Alpha value will be nothing but 0.01. Sorry, 90%, है ना? So 90% means
0.10.
yeah. 0.10. 0.10, or you can simply say 10%. So alpha is this much. Two-tailed test. This is not a two-tailed test. This is a one-tailed test. And again, when it comes to one-tailed test, let's again quickly draw that diagram. So average radius 0.05. So the company claims that it can manufacture straw with average radius of 0.05 or less than that. Let's say 0.04, 0.03, something like that they can produce. So this part of the graph actually talks about H naught. This part of the graph actually talks about condition where H naught is true. Yes, we don't want to make H naught true. We want to reject H naught. So we will move in this direction. We will move in this direction. So for us, this is what? This is a right tail test. If we keep it right tail, only then we will be in a state to reject H naught. So this is a right tail, or I can say right one tail test, isn't it? Right one tail test.
Yeah.
This is what we have. Now, as far as validation techniques are concerned, we'll start with that tomorrow because we have to do a lot of things. For example, we have to understand how different kinds of charts, or rather different types of table work. So it would take some time. So it's better if we start tomorrow. And
Sure.
tomorrow we will be working on this Z test, T test. These two things we will work on. And then Z test, T test. Then we will be left with two more, chi-square and ANOVA. ANOVA will take one complete class. So tomorrow is what day?
14th
Tomorrow
of
is
July.
Thursday. Thursday.
Thursday,
Tomorrow is
yeah.
Thursday. So by
Yeah.
Friday we will be able to complete. By Friday we'll be able
Mhm.
to complete statistics. That means next week fresh. We'll start fresh, and from Tuesday, next week Tuesday, we shall be able to start with machine learning.
Okay, cool. Sounds good.
But again, when it comes to machine learning, we'll first have to complete EDA part. So data
Yeah.
visualization, EDA, we will do that first, and then
Yeah.
machine learning. So tomorrow and day after, okay, the next week, Tuesday, 19th. So 19th, 20th, 21st, at least these 3 days, we will have to give for EDA, exploratory data analysis, and then we can start with machine learning also. Okay, fine.
Okay.
So 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. Good enough. by the time you guys will be giving your test, by that time, a lot of portion of machine learning will be completed. Around 8 or 9 classes we will get for machine learning. We need more. I'm not saying that only 8 or 9 classes will be sufficient, but the point is before you give your test on 10th, you will be having some good material to study and prepare.
Okay,
So that
sounds
is
good.
nice. Okay. So for today, let's keep it till here. Tomorrow
Sure.
we shall
Okay.
continue.
Okay, yeah, no worries. Thanks, Ashutosh. Yeah, have a good day.
Yeah, thank you. Same to you.
Thank you. Bye.
Bye.